Hi, in this video I'm going to explain how to solve a circuit with AC sources using two methods. The first method, mesh analysis. So let's start with mesh analysis. To do the mesh analysis, it's better to have voltage source. So in this circuit, you will see that we have voltage source on the right hand side, but we have current source on the left hand side in parallel with the resistance 3 ohm. So the first step I'm going to do, I'm going to convert the current source into voltage source. How you do that? You just multiply the value of the current source by the resistance in parallel with it, which is 3 ohm. So we'll V, and or let's just use the letter E, and we call it E1. That's equal the current time the resistance R1. The current is equal 1 ampere an angle 40 degree times the resistance R1, which is equal to 3 ohm. When you multiply, you get 3 times 1 is equal 3, and the angle 40 degree, and the unit is volt. So that's the voltage source equivalent. Now I'll redraw the circuit using the equivalent voltage. So I will have the resistance will be in series with the voltage source, which is E1, and that's equal to 3 on angle 40 voltage, and the resistance is equal to 3 ohm. And we have capacitor. The capacitor was 2 ohm, so it would be minus G2 ohm. That's the impedance. And I have an inductor in the middle. That was 4 ohm, so it will be J4 ohm. Then I have resistance R2, it's 6 ohm. And the other voltage source was equal to E1, which is equal to 12 voltage on angle 0 degree. Then a ground, that will take it as a reference. Okay, so now I have two loops. I can use impedance notation to make it easier. So that's the impedance to the left. You have 3 ohm and negative J2, so that's Z1, which is equal to 3 minus J2 ohm. And I have on the right hand side another impedance. Let's call it Z3, which is equal to, you have only resistance, so that will be equal to 6 ohm. And in the middle you have another one, which we're going to call it Z2, and it's equal to it's only inductor minus J4, plus J4 ohm, so that's Z2. And then I complete the circuit by adding the voltage source. So the first one to the right, that's equal to E1, and it's equal 12 on angle 0, and the other one is E1, which is equal to, oh, there's something here, that's E2, I'm sorry, that's E2, and that's E1, which is equal to 3 on angle 4. Now I will assign the loop current for each loop, and we agree that it's going to be anti-clockwise direction. So we'll choose I1. We can choose on I1 to the right, and I2 to the left. So that's I1 and that's I2. So what's next? Now it's really easy, it's very simple. We'll do the same way that we did with DC circuits. So first I find the impedance, self-impedance Z11, and what would be the total impedances in loop 1. I have Z1 and I have Z2, so I'm going just to add them. Z1 is equal 3 minus J2, and Z2 is equal J4. I add the real with the real, will be 3 minus J2 plus J4 will be equal to plus J2 ohm. So I got Z11. I get the other Z22. Call all these self-impedance. Z22 will be equal Z3 plus Z2, because you know that's loop 2. You have only Z3 and Z2, so you add them. Don't change the sign, just add them. So you have Z3 that's equal to 6 ohm, and the other one J4, so it's simple, 6 plus J4 ohm. That's Z22. And then it will find the mutual impedance, Z12, and since we have just passive elements, so Z12 is equal Z21, where don't forget to flip the sign. What is the mutual impedance between loop 1 and loop 2? You have only Z2, so just J4, and you flip the sign for the mutual, so you have negative J4 ohm. You got the all impedances, so, and we have already the voltage, so go ahead and we start the matrix in the form Z times I equal E. So I'm just writing Ohm's law in matrix form. Z will be equal to Y11, the first element here, because this matrix, if we arrange it, we have 1, 2, 1, 2. So the first element 1, 1, Y11, I mean Z11, which is equal to 3 plus J2. 3 plus J2. Y22 will be here in diagonal, which is equal to 6 plus J4. And then you got the mutual one, Z12, Z21, equal minus J4. And the current that we're supposed to find, the values, I1, I2, equal the voltage. Well, for loop 1, let's just check the polarity. I1 in this direction and the positive polarity here. So it will be I1 coming out of the positive polarity. So it will be positive 3 over 40. So 3 over 40. And for other loop, you observe that the current going in this direction. So the current is entering the positive. So that will be negative E2, negative, the value that we have. What is the value of E2? 12 and angle 0. Okay, so solving this equation, there are many methods we explained before. You can do it even using MATLAB. You enter the Z, that's Z, you enter the Z, you enter the vector. You don't, I just be the result, and this one will be the E vector. So how you find I? You will write just I is equal to the inverse of the matrix Z times the vector E, and you will get the result. So of course you can solve them simultaneously if you wish. In any way, I did that on the computer. So I1, I found Z equal to 0.7887 ampere on angle negative 120 degree, and I2 is equal to 1.304 amp on angle 156. So that's the answer for the problem. Of course, if you want to find other things, let's say they ask about the current in I and J4, so you go and